Hi, this is Mr. Cerise, and I'm making this video to help you with the learning target. I can solve a linear system by graphing the linear system using the TI-84 Plus calculator to find the point of intersection. This is my linear system, 2x plus 4y equals 11, and negative 3x minus y equals 21. In order to use the TI-84 Plus calculator, I will have to take the equations in my linear system and solve them for y. So here's the first equation, where I subtracted 2x from both sides, divided everything by 4, and I have my equation in slope-intercept form. Y equals 11/4 minus 1/2 x. Taking the second equation, negative 3x minus y equals 21, I added 3x to both sides, and then I divided everything by negative 1. So my linear system has now been converted into both equations having slope-intercept form. Once I have the equation slope-intercept form, I can then use the calculator and go to the, turn the calculator on and go to where we have y equals. At y equals, I'm going to type in those lines so that we can ask the calculator to graph them and find their point of intersection. Making sure I'm to the very right here, I'm going to go ahead and type in the negative 1 divided by 2, and notice I use the negative sign, which is down here. And then to use the x, here's my x variable, and then that was plus 11/4. 11 divided by 4. So I have my first equation in. I'm going down to the y2 for my second equation, which is going to be negative 3. So once again, I'm going to use negative 3, and then here's the x. And then that's going to be minus or plus negative 21. So I have my equations in. Usually what we do first is do a zoom number 6. With a zoom 6, this will set the windows of the calculator so that the domain will go from negative 10 to positive 10, and the range will go from negative 10 to positive 10. As I look at this, I notice that my intersection point is in the upper left-hand corner, which is quadrant 2. So I'm going to go ahead and adjust my windows here, and so that I can get maybe a better picture of these functions. And because it was to the far left there, I'm going to change the domain for the x to negative 20. I'm going to change the domain for the x to 5 because I really didn't have any intersection or anything of interest to the far right on the graph. With the y min, there was not too much action or interest in what was in the bottom half of the graph, so I'm just going to have it go to negative 1. And then I would like to go a little bit higher on the range for the y's, so I'll go up to 20. So now what I'm going to do is I'm just going to press graph here, and then that'll save my windows, and you'll see now how the graph has changed the domain and range so that I have a nicer picture of the second quadrant. So if I press trace, I could try to trace over to where they cross, that point of intersection. But rather than do that, I'm going to do something better. I'm going to press second and then the trace button. And notice number 5, that's a function in the calculator that looks for the intersection of two functions. So I'm going to press number 5. And it's asking me to select my first curve. In this case, the curve is actually a straight line. So I'm going to hit enter because it has my first one. And then it went to the second curve, but wants you to verify that that's the correct one. So I'll hit enter again. And then it's going to ask me for it to guess the intersection point, and I will confirm that yes with an enter. And we can see here that these two lines crossed at negative 9.5 for x, and y equal to 7.5. So this is the solution to the linear system. So then I'm going to write my solution as x equals y equals, and then also as an ordered pair. What this means is if you use simple substitution and you plug this x in here and this y in here, then you should get 21 for the second equation and 11 for the first equation. I'll leave the check up to you. Thank you for watching, and I hope you found this helpful. If you have questions, please feel free to email me or bring them to class. Thanks for watching, and have a good day, good evening.